LeetCode 1315, sum of nodes with even-valued grandparent. Given the root of a binary tree, return the sum of values of nodes with an even-valued grandparent. If there are no nodes with an even-valued grandparent, return 0. The grandparent is a node of the parent of its parent, if it exists. That's a little confusing. So let me explain what they are asking, and then I'll explain the strategy. They're asking for the values of the nodes whose grandparent is even. So we look at this end node, the value is 9. Look at the parent, and then we look at the grandparent, that the parent of the parent value is 7. So we don't add 9. Likewise, we don't add 1 or 4. We look at 5. The parent of the parent, the grandparent, is 8. So we would add 5. And we would do the same thing for 1 and 3, whose grandparent is 6. 2 and 7, whose grandparent is also 6. The strategy that I employed for this is to start with a vantage point of the node we're on. If you think about, there's an inverse relationship between a parent and a child, and likewise for a grandparent and a grandchild. So if we want to know what the grandparent of 9 is, we could start from 7 and we could say, do we have a grandchild? And if we do, then we know what the grandchild is. And when we're on 7, we already know whether or not the value is even. So we can really traverse down this tree using a depth-first traversal. So we can do down the tree to the left, and then the right, and then, of course, the right of the other branch here. Adding to our sum the value of the current node if the current node is even. Actually adding to the sum the value of the grandchildren if the current node is even. So we look at 6. 6 is even. So let's look and see if we have grandchildren. Do we have a child? Yes, we do. Do we have a child of that? Yes. So we add that child, and then we add that child, and then we go on the right branch, and we add that child, and we add that child. Next, we go to 7. Okay, so 7, do we have grandchildren? Yes, but actually 7 is not even. So we don't have anything to add on there, so that whether or not we have grandchildren doesn't matter. So we're going to go into 7's children. So we're going to go to the left and to the right, 2 and 7. 2's grandchildren, we don't have any grandchildren. Same thing with 7. And ditto on the right side, we would look at 8. We don't have any grandchildren, but we do on the right side, so we'd add that. But when we got to 1, we don't have any children, and we got to 3, we don't have any grandchildren. And so that would be the terminating condition for that loop. Once we get to a node that doesn't have any children, we just add 0 and we go back. We're done with that adding stack frames onto our recursive calls. And so that's how this strategy plays out. Another way to think about it is if we were in battle and we had to figure out if we can go 2 hills in advance, and we want to know if we can do that safely. Well, the indicating factor for whether or not that is safe, if our munitions are in order, would be is the current node even? Are we even? And we can look 2 hills in advance. And that's the vantage point that we want to think about when we're coding this. We don't want to think about from the grandchild looking up. We want to think about looking down to the grandchildren to figure out if their node value is going to be added to the sum. And if it is, then we just add it and then go on to the child and repeat the process. So are we skipping over one generation from grandparent to grandchild? And so here's the code. We have our root. If it's null, we return 0. We get the left and the right properties. And so root is 6, left is 7, right is 8. If the root is even, then we add the left and right values of the children. So if 6 is even, then we're going to look left.left.val, add that to our sum, and add left.right.val. That's left.right.val. And if we can do that, and we add that to our sum. And then we do the same thing for the right. So if we have a right node, yes we do, then we add right.left.val, that's 1, and then we add right.right.val, that's 3. So now our sum should be 9 plus 3 plus 1, which is 11. And then we take this sum, which is 11, and we add up the even grandparents left. So we would look then to 7, which is left, and we would look at the see if 7 is there, sum is 0, we're going to get left and right. The root's value of 7 is not even, so that one's not going to add anything on. And the same thing with 8. Actually, 8 is even, so we would add that on. But in the case of 7, we would skip over 7, but we would still look to the children of 7, which is the left and the right. So we do need to maintain those extra pointers of left and right, and we only get the values of the left.left and left.right from the grandchildren. That's shown right here in this conditional statement inside of the condition determining if the node we're on is even. And that's how to solve this problem in JavaScript. And there you have it. Thank you for watching.